This is SpaceTime, Series 29, Episode 10, for broadcast on the 23rd of January 2026. Coming up on SpaceTime, the first nuclear rocket about to be launched into space, do low-mass dwarf galaxies merge, and the link between Earth-like planets and Jupiter-like gas giants. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
History is about to be made with NASA and the Defense Advanced Research Projects Agency DARPA getting ready to test the world's first fully operational nuclear-powered orbital rocket within the next few months. The new vehicle is based around a nuclear thermal propulsion system in which uranium undergoes nuclear fusion to heat a liquid hydrogen propellant, which is then expanded and exhausted through a nozzle to propel the rocket forward. The system is projected to develop thrust with a specific impulse of roughly around 900 seconds. That's nearly double the efficiency of conventional chemical rocket engines, which peak at about 450 seconds. The test will validate reactor operation in orbit, with nuclear systems remaining inactive during the launch, which will use conventional chemical rocket engines. The project saw NASA's Space Technology Mission Directorate undertake the technical development of the nuclear thermal engine, which was then integrated into DARPA's experimental spacecraft. DARPA also supplied the nuclear reactor for the project. The last nuclear thermal rocket engine tests were conducted by the United States more than 50 years ago under what was then NASA's Nuclear Engine for Rocket Vehicle Application and Rover projects. The nuclear thermal propulsion system could reduce Mars transit times by 25%, in the process lowering an astronaut's exposure to radiation and enabling larger payloads to be carried. However, the project still needs to navigate stringent nuclear safety requirements, complex reactor engineering, and of course, the ever-present political oversight. This is SpaceTime. Still to come, do low-mass dwarf galaxies merge, and the link between planet Earth and planets like the gas giant Jupiter. All that and more still to come on SpaceTime. A new study has confirmed that low-mass dwarf galaxies can and do merge with each other. The findings, reported in the astrophysical journal Letters, are based on new observations of the distant outer stars of our own galaxy, the Milky Way. Astronomers discovered a previously unknown structure surrounding a tiny satellite dwarf galaxy which orbits the Milky Way. The newly discovered structure is exhibiting features which resemble the remnants of past galaxy mergers. The findings are providing compelling evidence that even extremely low-mass dwarf galaxies may still experience mergers with other similar-sized galaxies. Numerous small satellite galaxies have long been gravitationally bound to the Milky Way, orbiting around it. These dwarf galaxies are often regarded as fossil galaxies, formed in the early universe, with their structures providing valuable clues to understanding how galaxies form and evolve. Traditionally, dwarf galaxies have been thought to form through relatively simple processes, such as gas inflow and outflow and internal star formation, meaning that galaxy-galaxy interactions or mergers were considered rare in such low-mass systems. However, recent observations by the European Space Agency's Gaia mission have revealed that in some dwarf galaxies, stars are distributed beyond their expected outer boundary, known as a tidal radius. Because Gaia observations are limited to relatively bright stars, primarily red giant branch stars, it's been difficult to investigate detailed distribution using numerous faint stars in the outer regions. As a result, it's remained unclear whether or not these extended structures are caused by tidal interactions with the Milky Way galaxy or whether they're intrinsic features formed through past small galaxy mergers. To get a better idea of what's happening, astronomers used the Subaru telescope in Hawaii to study a small dwarf galaxy orbiting the Milky Way known as the Ursa Minor dwarf spheroidal galaxy. This allowed them to investigate the faint stellar populations of the galaxy out to its outskirts beyond the nominal tidal radius. They detected many faint main sequence stars that were invisible to Gaia and successfully mapped their stellar distribution, extending into the very outskirts of the dwarf galaxy with unprecedented precision. Their analysis revealed that the stellar distribution extends not only along the major axis of the galaxy, which was previously known, but also along the minor axis. And the structure along the minor axis of this galaxy shows properties distinct from the elongation along the major axis, which is commonly attributed to tidal forces from the Milky Way. Now, this suggests that the minor axis structure may well have a different origin. The authors believe the minor axis structure discovered around the Ursa Minor dwarf spheroidal galaxy may have been formed through a merger between it and another dwarf galaxy. The study's lead author, Koyusuke Sato from the National Astronomical Observatory of Japan, says that the findings suggest that galaxy interactions and mergers may play a role in the formation and evolution of even extremely low-mass dwarf galaxies, with masses as small as just 1/10,000th that of the Milky Way. Sato says the studies revealed a previously hidden stellar structure in the outskirts of Ursa Minor, representing an important step forward in understanding the formation and evolution history of dwarf galaxies. However, to determine whether this structure was formed by tidal interactions with the Milky Way, or whether it really does represent a remnant past merger, more detailed studies using stellar kinematics and chemical abundances will need to be undertaken. And needless to say, we'll keep you informed. This is SpaceTime. Still to come, discovery of a link between Earth-like planets and Jupiter-like gas giants, and later in the science report, China breaks through a decades-long barrier which has limited nuclear fusion reactor development. All that and more still to come on SpaceTime. Astronomers have shown that rocky terrestrial planets similar to the Earth tend to occur more often in star systems which also contain large Jupiter-like planets in more distant orbits, just like our solar system. The findings, reported in the journal Astronomy and Astrophysics, are based on detailed computer simulations. They show that these so-called cold Jupiters tend to orbit beyond the snow line of their host stars' planetary systems. The snow line is the distance from a star where water tends to condense out of the protoplanetary disk as ice. The study's lead author, Martin Schlecker from the Max Planck Institute for Astronomy in Heidelberg, says the simulated Earth-like planets produced by the models end up being larger and more massive than the real Earth, but only have thin atmospheres and hardly any water or ice. He says they tend to populate the inner so-called temperate zones of their planetary systems, again just like Earth. And Schlecker points out that the Earth, despite its enormous oceans and polar ice regions, only really contains about 0.12% water, so technically it too qualifies as a dry planet, in line with what the simulations have produced. Schlecker's findings are based on a statistical evaluation of new simulations of 1,000 planetary systems that were evolving in a protoplanetary disk around a sun-like star. During these simulations, the planetary embryos collected material, grew into planets, changed their orbits, collided with each other, or were rejected from their planetary systems. Planetary systems that survived the evolution eventually had planets of different sizes, masses, and compositions, all on different orbits around their central star. The advantage of using computer simulations for this kind of work is that it eliminates the problems of hunting for real cold Jupiters, which will require years to identify due to their wide orbits around their host stars. Remember, even in our solar system, Jupiter takes 11.86 Earth years to complete each orbit around the Sun. Also, in real life, the technological limits of telescopes means astronomers are far more likely to find high-mass planets in close orbits around low-mass stars. Still, real observations made in recent years have shown that planetary systems with a cold Jupiter are almost always likely to contain a super-Earth as well. In fact, Schlecker says almost 30% of all planetary systems which contain a super-Earth also appear to have a cold Jupiter. It would be more plausible to expect massive planets are more likely to disrupt planetary systems during their formation in such a way that the formation of other planets would be hindered. However, Schlecker points out that these cold Jupiters seem to be sufficiently far away so that their gravitational influence on the development of smaller super-Earth-like planets appears to be rather small.
We studied the relations between inner super-Earth and outer giant planets that live in the same system. And we were wondering, is there a difference in the composition of a super-Earth when there's a cold Jupiter in the system compared to when there's none? We found that indeed there is such a difference, And it lies on the properties of the protoplanetary disk in which the planets have formed. In a nutshell, if you have a moderately massive disk, 100 Earth masses or so, we see that primarily icy cores form just beyond the ice line. They migrate to detectable distances, and we end up with systems of volatile-rich super-Earths of low bulk density. No giants are formed. If you have, on the other hand, a rather massive disk, several hundreds of Earth masses or more, you can form planetary cores further in, and they migrate inwards to become dry super-Earths. But the conditions are also right to form giant planets further out, and they prevent icy cores from migrating inwards. In this case, we get high-density super-Earths in the inner system, plus a distant giant planet. From this follows a testable prediction. If you find an inner super-Earth with a high density, you're more likely to find a cold Jupiter in the same system as well.
That's Martin Schlecker from the Max Planck Institute for Astronomy in Heidelberg. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study shows that diets are being displaced around the world by cheaper ultra-processed foods that are in turn increasing the rate of chronic diseases. The findings, reported in a series of papers in the Lancet Medical Journal, reviewed evidence on ultra-processed foods and found a shift towards these ultra-processed options was worsening diet quality, with obesity, diabetes, heart disease and depression among the conditions which have now been linked to these foods. The authors argue that these foods are often mostly sold by major global corporations, and policy changes such as increased food labelling, better marketing restrictions, and increased taxes are urgently needed to tackle this takeover. Scientists with EAST, the experimental advanced superconducting tokamak in China, have broken a decades-long barrier that's limited nuclear fusion reactor development. Tokamak fusion reactors rely on densely packeted superheated plasma inside a donut-shaped chamber, which is kept away from the chamber walls by powerful magnets. Instead of splitting atoms as conventional fission reactors do, which provides heat but also vast levels of radiation because of the uranium fuel they use, fusion reactors act like the cores of stars, fusing heavy isotopes of hydrogen atoms called deuterium and tritium together to generate heat with very little radiation. But one of the problems with fusion reactors until now has been the actual density of the plasma itself, a boundary known as the Greenwald limit, beyond which it becomes unstable. The new study, reported in the journal Science Advances, claims scientists have now been able to push beyond this limit to achieve densities of 30 to 60% higher than those normally reached, while still keeping the plasma stable. Well, as any dog owner will tell you, man's best friend can be especially good at learning words simply by eavesdropping on human conversations. I mean, you only have to use the word vet or simply spell it a couple of times and Fido quickly works out its meaning. Now, a report in the journal Science claims this canine ability is comparable to that of an 18 to 23-month-old human child. The authors reached their conclusions by recruiting 10 dogs that had already proven themselves to be gifted at learning the names of objects, and then made them watch as their primary caregiver and another family member spoke in simple words about a new toy. As a group, researchers said the dogs were able to retrieve the correct toy when asked at a rate well above simple chance. They say this requires complex social learning, abilities that would normally take a human child at least 18 months to develop. Australians are being targeted by new AI-generated health experts doling out medical advice and even treatments. Deceptive social media pages claiming to belong to qualified medical professionals are now plaguing the internet. The Skeptic's Tim Mendham says people need to study these sites carefully to make sure they're dealing with real doctors. He says some AI-generated profile images show several telltale signs of artificial intelligence generation, things like distorted unreadable text on medical coats, 2 left arms, and 6 digits on one hand. But lots of others are far more difficult to tell apart from the real thing.
The bad thing about artificial intelligence is that it offers a lot of benefits, but also opens up a lot of avenues for all sorts of misinformation. And there's sort of increased number of doctors, in quotes, appearing on Facebook and offering either selling products or making particular claims about medical conditions. What it's showed to be is that a lot of these, or some of these anyway, are fakes. They're actually AI generated, which is very sad. There's one Melbourne-based doctor named Dr. Garcia, claimed to be part of the Australian Medical Association team, which doesn't make sense. One of the issues, though, is that you go for a cliche with this AI generation. You say doctor, i.e. white coat, stethoscope, makes them a doctor. It makes them, therefore, trustworthy, doesn't it? So, therefore, you can have anybody, in quotes, whether they're artificially created or what, say anything, and it will look impressive. Some of them were sourced from Nigeria or Afghanistan. Some of these things are working medicines which they claim have been approved by regulators, and therefore they sell them. The common goal is exploitation, whether financial or by spreading misinformation. People who do this for the fun of it are scary people, obviously, very sad, and people who do it to make money are evil. So just watch out. Just because it's on Facebook, obviously it doesn't mean it's true.
That's the Skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.